Alright, now we're going to look at some problems that we've got to prove. And of course you're going to use some of the half angle identities to help you out here, but you'll also use some of the identities that we've been using in the past already. Actually on this one, what you're going to want to do is start on this right hand side. So we need to go through, and I'm going to change everything to sines and cosines. So where I have secant b, that would be 1 divided by cosine b. That's just using your reciprocal identity. Okay, on the bottom, again, I have secant b, so that would be 1 over cosine b times secant, or cosecant b, so that would be 1 over sine. And then, of course, again, cosecant is 1 over sine. Okay, now I have a complex fraction here. So what you're going to want to do before you start multiplying everything by the common denominator, we do want to multiply these two together and just get that into one term. Okay. Now my common denominator is going to have to consist of sine times cosine. So each individual term we need to multiply by sine cosine. Alright, so in the numerator we're going to get the cosines to cancel. So that would just leave me with sine. Okay, in the denominator, of course you're going to get all of this to cancel with all of this, which would just leave you with 1. And then here your sines are going to cancel, which leaves you with cosine. And actually, if you look at your identities, let me pull them up here real quick. If you notice, this is this form of your half angle. So you've actually proved it. This is your half angle. So the last step would just be that this equals tangent of b divided by 2. Okay, next one that we're going to look at. Alright, this one has what I would say a good bit of algebra that you have to do on this one. Okay, I'm going to work on the left hand side with this one, and I've got the half angle for tangent. You can actually use, again, whichever one you want to, and I'm just going to go with that first one that I had listed. So I'm going to replace this with 1 minus cosine x divided by sine x. Now I have to subtract from that the half angle for cotangent. Well, that, of course, I didn't write down a half angle for cotangent, but all you'd have to do is just do the reciprocal of one of the half angles for tangent. So I'm going to take the one that I've just used for tangent and just do the reciprocal of this one. Okay, now you're going to need to get a common denominator. Okay, this first fraction, of course, you've got the sine x. What you're missing is the 1 minus cosine. So you already have a 1 minus cosine x, and now you've got to multiply it times a 1 minus cosine x. Okay, with this one, what you're missing is the sine x. So again, you've got a sine x on the top, and you're going to multiply it times sine x. So we'll go ahead and multiply that, which will give us sine squared. Alright, you are going to want to FOIL out your numerator here. So that's going to give us 1 minus 2 cosine x plus cosine squared x. And I'm just going to go ahead and bring this into one fraction. Alright, next step that you're going to want to take is you're actually going to want to replace your sine squared with 1 minus cosine squared, which is one of those identities that we've used in the past that's from the Pythagorean identity. So I'm going to make a substitution here. Now you do definitely need to keep it in parentheses because you're turning this one term into two terms, which means your minus sign is going to have to be distributed. Okay. Now, when you do distribute your minus sign, we'll kind of do this in our head. Of course, this is going to be a minus 1. So what's going to happen, of course, is this is going to end up canceling with this. But then when you distribute this, then this will end up being a plus. So you have a cosine squared plus a cosine squared. So like you'll end up putting these together. But like I said, this actually ends up being a plus here. Okay, so I've got my negative 2 cosine x. Combining those would then give me 2 cosine squared. Okay, now in your numerator you have a common factor of 2 and also a cosine. You're actually going to want to factor out a negative 2. So if I were to factor out a negative 2 cosine x from each term, of course that is that first term, which means I'll just have an understood 1 left. Of course my plus sign will change to a minus sign since I'm bringing out a negative, and then I have a cosine left. So then you get this to cancel with this. Let me just keep going this way. So now I've gotten it down to 2 times cosine over sine, but cosine over sine based on your reciprocal identity is cotangent, therefore you have negative 2 times cotangent x, which is exactly what we were trying to come up with. Alright, one more, and this one actually does different than what you're used to. You actually have to work on both sides on this one, which I know I've stressed to you, only work on one side, but for whatever reason that's the only way that this one works, and you do have one in your homework, which you will have to work on both sides. For all the other problems you will just continue to work on one side. Okay, let's start here. And this is your half angle. Of course, the half angle identity I gave you was just cosine to the first. So this just means take your half angle for cosine and square it. So I've got my 2 that's out front, and then I'm going to have plus or minus the square root of 1 plus cosine theta divided by 2, but then I have to square this. Okay, I'm going to get that side simplified down and then we'll come back to the other side. Okay, now I know I've got plus minus, but whether I square a positive or I square a negative, this is just going to end up being positive, so actually at this point you could just ignore that. When I square the radical, square the square root, then I'm just going to have what's underneath it. So then what happens is your 2's cancel, and you have 1 plus cosine theta. Then what we're going to be able to do is actually take this side and simplify it down to be the same as this. Like I said, this is just an exception here in which you're just going to have to work both sides. Alright, going back actually to what we've done in the past here, you're going to replace your sine squared with 1 minus cosine squared. That's just coming from your Pythagorean identity. And then your 1 minus cosine squared is a difference of squares. Again, we've seen that before. So that's 1 plus cosine times 1 minus cosine. So then what happens is the 1 minus cosines cancel out, and you're left with 1 plus cosine.